Constructors are the part of your class that are responsible for creating or constructing the object. In this lesson, I'll show you the basics of how to use them, including issues with inheritance and how to do constructor overloading. So to demonstrate constructors, let's first create a class. We'll create a customer class, and you can make these very nice C# properties with nice sugar-coated property syntax. And this means that the properties will be available outside the object. And then you can make your constructor here and pass in a first name and a last name like this. And then you can assign first name equals first name. Or you can create the customer object and then just assign first name directly because it's a property. However, it's good practice to have more control over your classes. So instead of having open properties like this, you want to only expose those that you really need to. So what I do most of the time is make private fields like this. And private fields have an underscore as a convention in front of their names. So we have first name with an underscore and private string last name. And then we assign those to the properties to those. So we'll also do the same with last name. So now the only way to change first name and last name is to assign them when you create the object. So let's create an object, customer equals new customer, and you'll see with IntelliSense that it's asking for the first name and the last name. And so we'll type those in like this, and it now has them. Let's do a little display method so we can see if this worked. So public string display. And now instead of the properties that we used to have, we have to send back the, let's see, we'll put last name comma first name. Last name, actually we don't want that one, we want this one here, last name comma first name like this. So, and then we can display the customer. And let's see if that works. Yes. So we have a very simple use of the constructor, and the constructor is responsible for filling the private fields. So now I would like to demonstrate a issue that has to do with inheritance. So for instance, if we have a class called person, and the customer class inherits this like this, and the person class has a constructor, then it's important to know that when customer is created, when it's constructed, the constructor of the base class is always called. So we can put here, this will always be called unless some other constructor in the base class is explicitly called. It's a good rule to remember. And we can see that when this object here is created, let me debug through this. So I'll do an F11, and now we're in customer, and I did F11 again, and now we're in person. So now it's going through the person constructor, then it goes through the customer constructor, and then it's finished. That's important because you might have some kind of variables in the constructor of your base class that you don't necessarily want to be set or commands to be executed, and it's good to know that that constructor is always called. You can, however, as stated here, explicitly call a different constructor. So we could have a different constructor in the person class. For instance, if we wanted to accept first name and last name, since a person also has a first name and a last name, it makes sense. And so here we'll just say in first last name person constructor. So, and now we'll run it. And oh, it said here that it, okay, this is very interesting. it actually still went into the base constructor without any parameters. Why? Because we didn't, although we created it in person, we didn't explicitly call it in customer. And the way you explicitly call a constructor in a base class is with a colon, and then say base, and then send everything that you need. So the first name and the last name. Now when we run it, we'll see that it went into the explicitly called constructor in the base class. So that gives you control over which base class constructor that you call, but you have to call at least one, and if you don't call any of them, then the one without any parameters will be called. You may at some point be in a position where you have a constructor in your class here that inherits another class, and you don't want to execute all of the commands in the base constructor without any parameters, and you don't want to execute all of the commands in any other constructor. What you do then is, what's common, is to make an initialize method and make sure that it's protected so that the inheriting class can use it as well. And then you'll perform your specific commands here. For example, this initializes variables which only some derived classes need. And then you can move parts of this and parts of this in here and have pretty much complete control over it. If you need to call that, then you say initialize from here and call it explicitly. In some other classes that inherit person, you may not call it. So if we run it, we see that we called explicitly the first last name person constructor in person, the base class, and then we also called the initialize method to have other code run that we may not want to have run when we initialize other inheriting classes. So one other note I want to mention about constructors is that you can overload constructors in C#. And it doesn't have to do with inheritance, so let's go ahead and just take all this out. I'm doing Control-K, Control-C to comment all that out. And when we do that, of course, all of this has to come out, since that was in the base class. So now we have here a customer class that has a customer constructor that asks for a first name and a last name. What if we also want to have a constructor that only takes the last name? Well, we can do that. Let's just copy this whole thing. That was Control-C, Control-V. And so we say, just pass me in the last name, and then we just have to save the last name. And so when we construct an object, equals new customer, we see here that we have two constructors to choose from, and you can have as many as you want. One note here, this code isn't 100% clean because in this line is repeated code. And if we ever wanted to change this one, we would have to remember to change this one, which is, in this example, no big deal. But if you have 20 constructors, it becomes a big deal. So better design would be to, for the one that accepts first name and last name, to take this one out. Okay, that's fine. Now it's not repeated, but how do we have last name be assigned when this constructor is called? And the answer is with the, just like the base, the this keyword. And so we send last name, and this means this object. So let's go ahead and step through this. If we run it, I press F11, and now it's in the main constructor. I press F11 again, and it already went to this, passing a last name, so it goes to this constructor. And it goes through that, assigns the last name. The last name is now assigned. The first name is not assigned. But now that it's back here, it goes through the original constructor. And now the first name is assigned. So if we let it go, F5, then it assigns all the values in the class. So in this lesson, you learned about constructors, a basic concept in object-oriented programming. You learned that a base constructor is always called. Even if you do not explicitly call it, then the empty constructor on it is called anyway. And you learned how to override constructors so that your classes offer multiple ways to instantiate them.